In this paper, we introduce ARRO, a method for enhancing the robustness of visuomotor policies under visual domain shifts. ARRO leverages open vocabulary segmentation to isolate task-relevant elements and overlays them onto a structured virtual background. This abstraction is applied consistently during both training and inference, resulting in robust policy behavior across variations in different environments or robot embodiments. To better visualize the approach, here you can see a task where the robot must drop a cube into the box and close the lid. The videos show the training and an inference scene with significant visual changes in background and robot appearance. In the bottom row, you can see ARRO, where only task-relevant regions are overlaid on a structured grid. As an ablation, we also try using a plain black background to isolate the effect of adding virtual cues. We evaluated ARRO on 4 tasks, introducing visual domain shifts during inference. ARRO outperformed both vanilla and mask diffusion policy by preserving only task-relevant parts and adding structured visual cues. We also evaluated the robustness of our approach to distractor objects and spatial reasoning. ARRO successfully performed the tasks by correctly identifying the desired object, whereas the vanilla policy often failed or behaved inconsistently. Here we take a closer look at the doll task. Visibly, we see that despite the rich textures and shape changes of the objects, ARRO segmentation remains reliable.
ARRO can also improve the visual robustness for generalist VLA policies such as Octo and OpenVLA. We also evaluate ARRO on zero-shot real-to-sim generalization, where we train the models on real data only and evaluate in simulation. Our results show that ARRO is consistently outperforming vanilla and mask versions, as shown with these reward plots. For OpenVLA, we achieved the best real-to-sim transfer, where the vanilla version fails completely, while the ARRO version retains 22% success probability. Cross-embodiment policy training still remains a challenging domain. When changing to the new UR5E embodiment, the performance of the diffusion policy drops to 0. With ARRO, however, we show that the embodiment change does almost not impact its performance. In this work, we introduced ARRO, a calibration-free visual augmentation pipeline for visuomotor policies. We show its effectiveness on a selection of real-world experiments in real-to-sim and cross-embodiment setups, and for a range of different models. Using setup-invariant visual representations like ARRO will allow us to bridge gaps in robot embodiment, lab, and simulation setups.